Hello everyone, my name is Bruno Góis Mateus. I'm a PhD student at l'Université Polytechnique Hauts-de-France, and I will present my research named on the adoption, usage, and evolution of Kotlin features in Android development, which was developed together with my co-author Matias Martinez. Historically, Android applications have been mostly developed using Java, but in 2017, Google announced Kotlin as official programming language of the Android platform, bringing a new option for developers to write mobile applications. After that, some studies in the literature reported that around 11% of Android applications have adopted Kotlin. More recently, in 2019, Google announced that Android developers would become increasingly Kotlin first, which means that new APIs and features will be offered first in Kotlin and later in Java, and we believe that this fact will boost the use of Kotlin in the context of Android development. Kotlin is a programming language that provides a different approach to write applications. It is fully interoperable with Java because it runs on the top of the JVM, the Java Virtual Machine. Then you can mix Java and Kotlin together. Also, it combines object-oriented and functional features, and some of these features are not available in Java or not available for Android development. To give an idea about which kind of features we are talking about, let's see some examples. Here in the Kotlin snippet, we have two different features in use, type inference and safe call. Due to the type inference, we do not need to declare the type of the variable result. This type will be inferred according to the next statement, which has a safe call. In this case, method 2 will be executed only if the null label var is null. Otherwise, method 1 will be executed, and according with this execution, the type of result will be inferred. In the Java snippet below, we have the same logic implemented using Java optional. However, Java options are not available for all Android devices. To use Java optional, you have to use the Android API 24 or higher. In this second example, we have string templates, another feature. With string templates, you can embed Kotlin expression inside strings, and this expression will be evaluated later and the value will be substituted in the strings. In Java, the way of doing that is using a lot of concatenations, as you can see in the snippet below. Therefore, Kotlin features bring new opportunities, new ways of writing mobile applications. However, to the best of our knowledge, there is no study in the literature about the adoption of Kotlin features by Android developers. Because of that, we focus on the usage of Kotlin features in this research, and we answered 3 research questions. Research question 1. Which Kotlin features are adopted by Android developers? Research question 2. When do Android developers introduce Kotlin features during applications evolution? Research question 3. How the usage of Kotlin features evolve with the evolution of Android applications? To answer research question 1, we focus on Kotlin features not available in Java or not available for Android development. We identified those features by navigating through the official Kotlin documentation and Kotlin release notes. Then we built a tool that operates at the level of the abstracted syntax tree, and we encoded analyzes to detect 26 features. After that, we analyzed applications from Famazoa, the largest publicly available dataset of open source applications written in Kotlin. In total, we analyzed 387 open source applications written fully or partially in Kotlin. And we found that Android developers use all the studied features, as we can see in the plot here. Also, we found that 7 features are used at least in 80% of applications, and that the most used features are type inference, lambda, and safe call. To answer the research question 2, for each application, we identified the first commit that introduced Kotlin code in that application. Then, for each feature, we identified the first commit that introduced a feature. And then, we counted the number of days between the introduction of Kotlin and the introduction of a given feature. And we found that in the following 10 days after the first commit with Kotlin code, 15 out of 26 features are added into Android applications. And the most used features tend to be introduced in the first commit with Kotlin code, as you can see in the plot here. In the research question 3, we investigate possible scenarios of evolution trends usage. For instance, if a given features all increased number of instances along the evolution of application, if a given feature tends to be introduced only once or few times and then the number of instances gets stable. Or another example, if a given feature do not present a clear trend, varying between addition and removal of instances. To determine the evolution trend that dominates each feature, we calculate the series of the number of instances per application. Then, for each commit, we counted the number of instances of each feature, and we generate some plots. Analyze those plots, we established 11 major feature evolution trends that we show here in those plots. To automatically classify the evolution trend of a feature, we mapped these trends to 5 mathematical formulas. Linear, which we can use to detect 3 trends: constant rise, constant decline, and stability. Exponential, that we use to identify 2 trends. Logarithmic, that we use to identify 1 trend. Sigmoid function, that we use to classify 4 trends, and a polynomial function that we use to classify 1 trend. We use the SciPy library to fit our formula with the series, and using the nonlinear least square error, we choose the formula that yields less error to predict the values. Here we have some example of the fitness data. And we found that developers tend to add more instances along the evolution of Android applications of 24 out of 26 features studied. And we found out the most common trends that better describe 24 features are constant rise, where the number of instances increases along the evolution in a constant rate. Plateau gradual rise, where we have a period of stability of the number of instances, and then in a sequence of consecutive commits, we see an increase in the number of instances, and then it gets stable again. And plateau sudden rise, which is similar with the previous one, but the main difference here is the rise of the number of instances happened exactly in 2 consecutive commits. Finally, we conclude that Android developers are exploring all Kotlin features, including the experimental ones. For instance, coroutine, which was experimental until November of 2019, and control, that is still experimental, and we found some instances in our dataset. We also found that the most used features are added at the same time that Kotlin is introduced into applications. And along with the evolution of application, the number of instances of Kotlin features increase. Thank you very much for your attention, and bye.